The Cafferty Group, technical service advisors with offices located in Nebraska, Iowa, Kansas, and Colorado, presents Essential HVAC Principles Training, HVAC Physics, Concepts, and Theory. Principles of matter, the states of matter. A solid is defined as a substance that has a definite shape which it will hold under a certain degree of stress of pressure, depending on the materials and the type of disturbance. Liquid is defined as a substance that can take the shape of any enclosure when it is allowed to move freely, but the volume remains constant. Gas is defined as a substance that has no fixed shape or volume. Density, specific gravity, and volume. Density, which is mass per unit volume. Which is heavier, steel or aluminum, and why? Specific gravity. The weight of a volume of material compared to the weight of the same volume of water. We know ice floats in water, but why? The specific gravity of water is 1. The specific gravity of ice is 0.91. Even though ice is just frozen water, the specific gravity is less, so it floats. Question: what is the difference between density and specific gravity? Density is the amount of mass contained in a given volume. Specific gravity is the ratio between a substance's density and the density of a reference substance, typically water, at 39.2 degrees Fahrenheit, which is the temperature that water is at its highest density. Specific volume. Volume occupied by a unit mass of a substance under specific conditions. Boyle's law says, the volume of a gas varies inversely as its pressure if the temperature of the gas remains constant. Question: how does this explanation affect the characteristics of the refrigerant used in a system? Compressor operation. For a baseline, we will use 1 cubic foot of gas at 15 psia, which is pounds per square inch atmosphere. So a decrease in volume and a decrease in wall area would result in an increase in pressure. So if the volume was decreased to 1/2 of a cubic foot, the pressure would increase to 30 psia. Charles' law says, a volume of gas is directly proportionate to the absolute temperature, provided that the pressure remains constant. The absolute pressure of a gas is directly proportionate to the absolute temperature, provided that the volume is kept constant. So in compressor operation, baseline refrigerant vapor of 1 cubic foot with an atmospheric pressure of 14.7 psi. As the temperature is increased and the volume remains the same, the pressure is increased. If the volume is decreased, temperature is increased. So an atmospheric pressure of 14.7 psi be a temperature of minus 41 degrees Fahrenheit and a density of 0.2954. So let's talk about heat and refrigeration. What is refrigeration? Refrigeration is a process of removing heat from one substance and transferring it to another substance. What is heat? Heat is a form of energy. Quantity and intensity. Heat intensity is measured by its temperature, commonly in either degrees Fahrenheit or degrees Celsius. The quantity of heat contained in an object or substance is not the same as its intensity of heat. For example, the hot desert sands contain a large quantity of heat, but a single burning candle has a higher intensity of heat. Two types of heat. Sensible heat, which is heat that is added or removed from a material that causes a change in temperature of the material without a change in the material's state. This heat can be sensed using a thermometer. And latent heat, that is heat that is not sensed by a thermometer, but it is required to change the state of a substance. Quantity and intensity. Volume differences. These two different masses of water contain the same quantity of heat, yet the temperature of the water on the left is higher. Why? Measuring heat quantity. The BTU, or British Thermal Unit, is defined as a quantity of heat energy required to raise the temperature of 1 pound of water by 1 degree Fahrenheit. Maybe that could be explained by the laws of thermodynamics. What is meant by the following statements? Energy can neither be created nor destroyed. It can only be converted from one form to another. To cause heat energy to travel, a temperature difference must be established and maintained. First laws of thermodynamics. What it states is that the total inflow of energy into a system must equal the total outflow of energy from a system, plus the change in energy contained within the system. What it means? Energy cannot be created or destroyed. The second law of thermodynamics. Heat will only flow from a material at a certain temperature to material at a lower temperature, meaning heat is attracted to cold. The transfer of heat will occur using one or more of the following transfer methods: conduction, convection, or radiation. The principles of heat transfer. Heat always flows from a higher temperature substance to a lower temperature substance. The heat can be transferred from one substance to another, but heat energy cannot be destroyed. Methods of heat transfer. Conduction is the process of transferring heat through a solid. Convection is a process of transferring heat as a result of the movement of a fluid. Convection often occurs as a result of the natural movement of air caused by temperature density differences. Radiation is the process of transferring heat by means of electromagnetic waves emitted due to the temperature difference between two objects. An interesting thing about radiated heat is that it does not heat the air between the source and the objects it comes in contact with. It only heats the object itself. The rate of heat flow is 12,000 BTUs per hour. When 1 pound of ice melts, it absorbs 144 BTUs. Therefore, when 1 ton, 2,000 pounds, of ice melts, it absorbs 288,000 BTUs, 2,000 times 144. Consequently, 1 ton of refrigeration absorbs 288,000 BTUs within a 24-hour period, or 12,000 BTUs per hour. That's 288,000 BTUs divided by 24 hours. So 1 ton of refrigeration is defined as the transfer of heat at the rate of 12,000 BTUs per hour. The effect of transferring heat. Sensible heat. measurable temperature change occurs. Using the same volume of water, 1 pound of water at 60 degrees Fahrenheit plus 1 BTU of heat would raise the temperature of that 1 pound of water by 1 degree to 61 degrees Fahrenheit. 3 types of latent heat: latent heat of vaporization, latent heat of condensation, latent heat of fusion. Effect of transferring heat. Latent heat. Heat is transferred, but temperature remains constant. There is a change of state that occurs. So the same volume of 1 pound of water heated to 212 degrees plus 970 BTUs equals 1 pound of steam, also at 212 degrees. So we've changed the 1 pound of water to 1 pound of steam without changing the temperature. Specific heat. Even though equal quantities of the 2 liquids were supplied with the exact same amount of heat, why does liquid B reach a higher temperature than liquid A? The reason is that liquid B has less capacity for absorbing heat than liquid A. The capacity for absorbing heat is called specific heat. The specific heat of a substance is defined as the quantity of heat in BTUs required to raise the temperature of 1 pound of that substance by 1 degree. The 3 states or phases of water at atmospheric pressure. Let's start with ice at 32 degrees. It takes 144 BTUs of latent heat to turn 32-degree ice to 32-degree water. It takes 180 BTUs of sensible heat to change 32-degree water to 212-degree water. It takes 970 BTUs of latent heat to change 212-degree water to 212-degree steam. This also works in reverse. Changing water to steam is heat of vaporization. Changing steam to water is heat of condensation. It also takes 180 BTUs of sensible heat removal to cool 212-degree water to 32-degree water, and 144 BTUs of latent heat removal to change the state of 32-degree water to 32-degree ice. This chart also shows that to change the state of 32-degree water to 32-degree ice requires 144 BTUs of latent heat. Changing 32-degree water to 212-degree water takes 180 BTUs of sensible heat. Changing 212-degree water to 212-degree steam and 212-degree steam to 212-degree water requires 970.3 BTUs of latent heat. This is a pressure-temperature chart for 410A refrigerant. This chart shows liquid and vapor pressures and converts that line pressure to temperature. Thank you for joining us for Essential HVAC Principles, HVAC Physics, Concepts, and Theory. If you have any questions or need more information, please contact the Cafferty Group Technical Service Advisors at one of our 12 locations.